Hello, welcome to Sailor's Space, the Engineers and Navigators Hub. Today I'll be reviewing questions and answer on air compressor and starting air system. This question and answer is important to students who are studying engineering, people that need read up and reviews for interview preparation, students that are preparing for certificate of competency class 3 examination, and anyone that generally wants to learn and know more about engineering. This will be really helpful. Also, stay with me right till the end and you benefit really from this session. Please, if you have not subscribed to Sailor's Space, help us encourage us to do more better. Subscribe to Sailor's Space, like this video. If this video is interesting, if you've ever benefited from Sailor's Space video, give us a thumb up to help us spread the video to a greater audience. Click on the notification bell so you can receive notification whenever Sailor's Space uploads a new video. Stay right in as we delve into this review on questions and answers relating to air compressor and air starting system. Question review on air compressor and air start system. Question 1. Give reasons and remedies for the following faults in air compressors. A. Failure to deliver air. B. Compressor overheating. C. Compressor valve and seat erosion. Give reasons and remedies for the following faults in air compressors. A. Failure to deliver air. B. Compressor overheating. C. Compressor valve and seat erosion. Possible answers, although there may be other ones. For failure to deliver air, number 1, the suction line may be blocked. Number 2, dirty air filters. Number 3, valve improper lead installed. Number D, suction valve unloader stuck in unload position. And the final one, strip missing from valve. Possible remedies, although there are other ones, you can add that up for us in the comment section. I would love to hear from you. Number 1, clean or replace filter as necessary. Number 2, overhaul the valve. Number 3, open the discharge valve. Compressor overheating. Possible causes: poor ventilation. Number 2, blocked radiator or cooling fins. Number 3, discharge pressure higher than rated or normal. Number 4, insufficient lubrication. Number 5, wrong direction of rotation in some compressor. Possible remedies: number 1, clean and inspect coolers. Number 2, inspect the cooling water system and rectify possible problems. Number 3, overhaul the delivery valve. 4, check filters for dirt and clean them. Number 5, change pipe to specified diameter or size. Compressor valve and seat erosion. Possible causes: number 1, while drawing damp air, there may be carbon formation. Number 2, metallic dust from wear of parts. Possible remedies: check sum level and maintain gauge level. Number 2, reduce running periods and load on the compressor. Sketch diagrammatically a two-stage reciprocating air compressor. Label the principal features and show direction of air flow. Give reasons for compressor in stages. Give reason for interstage cooling. Give reasons why stages are often in tandem. Sketch diagrammatically a two-stage reciprocating air compressor. Label the principal features and show direction of airflow. Give reasons for compressor in stage. Give reasons for interstage cooling. Give reasons while stages are often in tandem. The diagram below shows a two-stage reciprocating air compressor. We have the inlet, which goes to the inlet valve. From the inlet valve, the air is being compressed. The air goes out from the discharge valve into the intercooler. After being cooled, it enters into the second stage, inlet valve. The air is being compressed and leaves the cylinder through the discharge valve, as indicated outlet. Reasons for compression in stages. Number 1. The work done in compressing the air is reduced, thus power can be saved. Number 2. Prevents mechanical problem as the air temperature is controlled. Number 3. Machine is smaller and has better balance. Number 4. Reduce thermal stresses due to low temperature, and this helps increase the valve life. Less ring leakages, improve liner and ring lubrication, less carbon buildups, and also prevent fire or explosion risks since the temperature is low as compared to a very high temperature. Reasons for interstage cooling. Number 1. To cool the compressed air at constant pressure, causing a reduction in mass volume of the air. Number 2. Reduction in temperature makes lubrication of the later stage liners possible and also adds to the safety of the system. Another importance of interstage cooling is that moisture in the air and perhaps oil vapor may condense and can be rid of by the help of the drains. Reasons why stages are often mounted in tandem. 2 or 3 stage compressors are constructed to increase air pressure when air is compressed in stages. It is easier to control the temperature of the air as different stages have different intercoolers, and to hold it at lower temperature during its passage through the air compressor. And hence the idea of mounting this compressor in tandem can give the following benefit. The load is on one crank through spread over 2 bearings. This leads to a reduction in moving parts as well as reduction in maintenance and overall cost that would have followed that maintenance. Also, for the same final pressure, the overall size and weight of the machine is less as compared to a standard reciprocating air compressor that is not constructed in tandem. Tandem mounting of compressor involves the low pressure and the high pressure stage piston being mounted on one crank through and requires the high pressure piston to be attached to the top of the low pressure piston. Question 3. Why is it dangerous to operate air compressor without inlet air filter? B. What is the first step in locating the fault if the compressor begins to lose capacity? Question C. What effect can excessive temperature have upon valves, and what examinations should be made if the temperature has been too high? A. Why is it dangerous to operate a compressor without inlet filter? Effort must be made to have only clean, dry air at the compressor intake because polluted inlet air may cause an explosion within the air compressor discharge line or receiver. When air compressors are operated without inlet air filters, foreign matters such as abrasive in air are allowed to enter the compressor, they combine with oil to form abrasive-like paste, which will increase wear on piston rings and liners and may choke the valves. They may stick to valves and make them not to close properly. This may lead to higher discharge temperatures and formation of carbon deposit. The carbon deposit could become so hot on valves that are not closing properly and act as igniting points for air and oil vapor mixture, thereby leading to possible fires or explosions in the compressor. Steps to take when an air compressor begins to lose capacity. Look at the pressure and temperature gauges on the various stages. Any variation from the normal ratio of pressure to temperature will indicate the probable trouble. Also, the air inlet filter fouling or clogging will reduce air throughput into the engine cylinder, which can lead to the compressor losing capacity and also raise the temperature. Hence, the inlet air filter should be checked for fouling and cleaned properly if necessary. Sluggish valve action and leaking valve can also cause a reduction in the capacity of the air compressor. So if this is detected, the valve should be overhauled. Effect of excessive temperature on valve. Excessive temperature can cause wear down of valve. It can cause the valve spring to be weak. It can also cause carbon accumulation to the valve seat. This can lead to the valve not sitting properly or getting stuck in either the open or the closed position that can lead to a reduction in the efficiency of the compressor. Some examination made if there is high temperature may include some of the following. Examine the valve spring to see if temperature drawing has made them sluggish or weak. Examine the valve seat for carbon accumulation. Examine the valve generally for wear down and carry out a valve overhaul to bring back the valve to normal working condition. With reference to air compressors, explain the purpose of A. Suction filters, B. Drain valves, C. Bursting discs, D. Relief valves. During the compression stroke, foreign matter such as abrasive, dust, etc. find its way into the compressor. The suction filters are fitted to the air compressor at the suction side to prevent these foreign matters from entering into the compressor. Drain valve is fitted to the air outlet of the air receiver to remove condensed moisture and oil which is accumulated in the air receiver and also relieve the air bottle from overpressure. The bursting disc is provided at the air cooler of the compressor. It is a safety disc which bursts to relieve excess pressure above preset value due to leaky air tubes of the cooler. The relief valve is fitted after every stage of the compressor on the high pressure stage to relieve excess pressure developed inside the air compressor. Question 5. With reference to air reservoirs, that is air bottles, sketch a mounting showing the manner of its attachment. Explain why regular internal inspection is advisable. Differentiate between specific functions of relief valve and fusible plug. The diagram below shows a pressure gauge and the manner of its attachment to the air reservoir. Explain why regular internal inspection is advisable for air reservoir. Air reservoir can corrode from the inside due to moisture in the air and hence require regular certified inspection. The combination of corrosion and high air pressures can potentially cause them to explode if they are not regularly inspected and maintained. Differences between specific function of relief valve and fusible plug. The relief valve is fitted to the air reservoir to relieve excess pressure inside the air reservoir or air bottle. The fusible plug is fitted in the air reservoir with a separate connection leading out of the engine room so that in the event of fire, this plug will melt, say at 150 degrees C, and relieve all the air in the air bottle to the outside temperature. Question 6. Explain how sluggish action of the suction and delivery valve reduces the volumetric efficiency of an air compressor. During suction of air, valves are lifted by springs to admit air. If the springs becomes weak due to high temperature or carbon is deposited on spring clearance, and there is no prompt reset after suction stroke, air drawn into the cylinder will be returned through the defective suction valve. Also, if a delivery valve is slow to reset, the compressed air or part of the compressed air will return to the cylinder during the part of suction stroke. This reduces the volumetric efficiency of the air compressor. Question 7. Explain why most high-pressure air compressors are multi-stage. B. What is the purpose of the air compressor after cooler? C. What would result if the suction valves were given too much lift? D. In a stage compressor, what is indicated if the intercooler temperature is too high? II. If the intercooler temperature is too low. Most high-pressure air compressors are multi-stage because air can be more economically compressed by multi-staging, with intercoolers between the stage in which the heat due to compression in the preceding stage is removed before entering the next stage. Multi-stage is also necessary to prevent temperature within the cylinders and receiver from reaching dangerous limits, and this prevents risks of fire and explosion, prevents lubrication problems and carbon buildups on valves, and also reduce thermal stresses as well as increase the lifespan of the air compressor. The aftercooler is fitted at the air outlet of the final stage delivery of the air compressor to remove moisture from the compressed air immediately after compression before the air enters into the air bottle or the air main system. If the suction valve is given too much lift, it may lead to weak spring, possible breakage of the valve, and also the valve would be late in closing and would reduce volumetric efficiency of the air compressor. If the intercooler temperature is too high, the following possible indication would help a watchkeeper detect it. Number 1, leaky inlet or discharge valve. Number 2, leaky rings or worn cylinders. Number 3, dirty coolers. Also, if the intercooler temperature is too low, the following indication can also help a watchkeeper detect it. Number 1, moisture accumulation. Number 2, low volumetric efficiency.